Hi, my name is Tom Graham, co-founder of MapD. I'm here to introduce our end-to-end big data analytics platform and the GPU in-memory database we built to power it. The database and big data analytics markets over the next 3 years are going to be worth $100 billion. But there's a massive gap. No CPU in-memory system can deliver millisecond latency analytics across billions of data points as they stream onto a system in real time. And this is exactly the problem faced by our development partners. So at MapD, we built an SQL database into the heart of GPU technology, and the results are hundreds and thousands of times faster than the status quo. So we're an SQL persistent database that delivers analytics straight from GPU memory. We don't use GPUs to accelerate one part of a process. What we do is process and execute queries straight from GPU memory, and we're limited by the constraints of memory bandwidth across multiple Tesla cards. So this is what it looks like. It's really fast. We can stream visualizations at 30 frames a second across multiple users. You can see our campaign finance map demo where you can mash up all political contributions over time with census data, and you can interactively network graph everything every politician has said in the last 20 years. Our tweet map demo allows you to analyze 1 billion tweets with full text. It runs off 8 Tesla K40s in a server, and we expand across nodes into a multi-cluster system. Everything is live. Nothing is pre-canned apart from a video, as you can imagine. So we've solved 4 of the major problems confronting big data analytics today. First, really fast queries. The MapD takes full advantage of the massive parallelism and memory bandwidth available on today's fastest hardware. And we work closely with NVIDIA to keep up to date. No CPU in-memory system can deal with that size data because CPUs and legacy database models were not designed around hardware constraints. The second big thing that we dealt with is lots of inserts. So we don't necessarily need to index given all the GPU power. We're working with PayPal to develop a system-wide architecture that can deal with the size and speed of their data and allow them to detect anomalies in real time. We do complex analytics, machine learning, things like neural nets at interactive speeds. We're working with Facebook to analyze every status update in real time so their analysts can identify trends and address malicious behavior in real time, not days later. The third big point that we've dealt with the fourth big point that we've dealt with is big data visualization. Using the GPUs, we can push high-definition visualization straight to browsers or mobile devices at 30 frames a second. We're working with NASA and the University of Colorado to speed up the scientific process by allowing their scientists to interact with historical satellite imagery in real time and track subtle shifts in climate change. Most importantly, we're at the forefront of the next chapter in data analytics, which is mobile devices with server-side streaming and MapD running on NVIDIA's next-generation Tegra chips. We can deploy a database across multiple devices and turn your smartphone into a supercomputer. The result is the next generation in big data analytics, where it becomes truly interactive. So our technology and our team come out of Harvard and MIT. Our advisors sit at the top of the database research and enterprise worlds. In fact, they're involved in founding the last couple of big in-memory database companies that now dominate the market. So we've got a great mix of experience and talent, and we're hiring as fast as we can. Our licensing model on the software side is very simple. We're going to launch it soon. To give you an idea of what's possible in the space, a leading vendor will sell you a server with the licenses that go with it for about $10 million over 5 years. And our customers that we're working with at the moment want hundreds of servers. So we're going to open source the academic core of MapD, and we'll build the enterprise model around that. Thank you very much.
Tom, thank you. Excellent job.